Assalamualaikum and hello everyone. We are from group 78 for course Skab 2012 Civil Engineering Laboratory 1. This video is about open-ended laboratory S1-SHEAR force and bending moment. And this is the lineup of our group members consists me, Muhammad Rozi bin Jaya, Muhammad Azmi bin Muhammad Sahran, Muhammad Ashraf bin Mat Zain, Muhammad Safwan bin Hamzah, and lastly Muhammad Amirul bin Muhammad Kamil. This is task distribution of this video. This is introduction for shear force and bending moment. The shear force at any point along the beam is a forces that tend to produce a sliding failure on a material along a plane that is parallel to the direction of the forces. And meanwhile, the bending moment is the moment induced in a structural element such as beam when an external force or moment is applied to the element causing the element to bend. Objective of this experiment is to study the shear force and bending moment at the particular section, which is section X to X, and compare with the theoretical calculation. Procedure for experiment 1, shear force. For this experiment, we need to conduct shear force variation at cut section due to variation of load and load position.
The apparatus to measure shear force is shown. This is point A, B, C, and D. This the cut section of SX where the shear force is measured. In case 1, the load 100 gram is placed between A and B. The value at shear force at section SX is measured. Next, the step is repeated with load 200 gram and then 300 gram. In case 2, the step is repeated by placing the load at any point between B and D. The value at shear force at section SX is measured. And last, in case 3, the step is repeated by placing the load at any point between D and C. Of Fx will be measured.
After that, we need to plot a graph relates to the measured shear force with position at the applied load P and graph that relates to the measured shear force with the magnitude of the applied load P. Next, we need to determine the positive shear force and negative shear force. The objective is for we use the measure shear force from the previous part and draw shear force diagram for each cases. The measure shear force will be positive or negative when the applied point load is applied at different part of beam. Take this case as example. This is the shear force diagram and the measure value of shear force is shown.
Apply at least 3 point load where each point load have same magnitude and same distance from each other. Then calculate the uniform load using the formula of total load applied over distance. Next, we need to calculate the value of shear force at section X by using the formula. And And lastly, we need to compare the calculated value of shear force with the measured shear force at section X. So for all these three cases, we need to do at different places. At section XX, where independent load is applied at point 1, point 2 and point 3. Next, we also need to measure the shear force at section XX when all the independent load is applied at the same time. Then we apply the superposition principle, which is total shear force is equal to the summation of shear force at section SS when independent load is applied at P1, P2, P3. Lastly, we need to discuss whether the measured and calculated value of shear force at section XX obey to superposition principle.
Hi, I'm Ashraf. To conduct experiment bending moment variation at cut section due to variation of load and load position. We need to set up apparatus as shown like this. Point A, B, D, C are marked on the beam where point D are direction X to find out bending moment at this point. For bending moment to variation of load, we apply 100 gram in between A and B, and the experimental force was recorded. And we increase the load to 200 gram and 300 gram. For the bending moment variation and transition due to load position, after we complete the bending section A and B, which is case 1, we repeat at the same procedure as case 1. Placing load in point B and D, the same 300 gram of load also, and point D and C. So that plot graph bending moment at X versus position of the load, and graph bending moment at X versus magnitude at the load. For positive bending moment and negative bending moment, we refer back the result in experiment bending moment into the load position and plate shear force diagram and bending moment diagram for each cases. We observe that the bending moment and the cut section SS that will be either positive and negative due to variation of load position. And this is example for diagram for case 1. Next, to prove positive bending moment and negative bending moment are absolute equal value. In plot bending moment in diagram of beam where load applied with distance D less than 240 mm from point B. We observe the maximum swagging moment. This equal to the absolute value of the maximum hanging moment. For the experiment bending moment, due to uniform distributed load, the setup is like this. This is point A, point B, point D, and point C. The section XX is at point D. The first step is we put the 3 mesh of load point P between B and point D, and the distance between the load P is same. Then we measure the distance between D to load at point P, then we will get the bending moment. After that, we repeat the procedure with adding one more point load at P with 3 same load between the point B and point D. Then repeat with change the load point P of 3 same mesh of load P between A and point B. And lastly, we compare the theoretical value, which is the calculation, with the experimental value. Next, for the experiment point of contraflexure for this experiment, the setup is like this. This is point A, point B, point C, and point D. The section XX is at point D. The first step is we need to put the load W at point A. Then we put load P between point C and point D. Next, we measure the distance between point C to load P, and then we will get the bending moment at section XX, which is at the point D. Lastly, we compare the theoretical value, which is the calculation, with the experimental value.
For the superposition principle, we are going to calculate and measure the bending moment at section XX here. The loop variation are same. First, we are going to measure the bending moment when load is applied at point 1 here. So we take the reading and record it. The distance for the load applied as shown in the figure. Next, we repeat the step by changing the position of load to point 2, point 3, and point 4. Take the record of the digital meter display. Then we need to measure and calculate the bending moment at section XX for 4 load applied simultaneously. Then we take the reading. Lastly, to know whether the load apply is super simple or not, we are going to use this formula. Thank you. That's all from us.